Other miscellaneous components in Apache Ant. We are focusing on other miscellaneous components. Here you can see the basic structure of an Ant build script. In the anatomy of Ant script, a typical Ant script consists of single build.xml file. The root element of the build script is the project tag. Within the project element, there are one or more targets specified. A target contains a set of tasks to be executed. The project element can specify a default target if no target is chosen during execution of the build script. As an example, we can consider listeners and loggers. A listener is alerted of following event: build started, build finished, target started, target finished, task started, task finished, message logged. These are used internally for various recording and housekeeping operations. However, new listeners may register on the command line through the dash listener argument. Loggers extend the capabilities of listeners and add the following features: receives a handle to the standard output and error print streams, and therefore can log information to the console or the dash log file specified file. Logging level dash quiet dash verbose dash debug aware, Emacs dash mode aware. Here you can see an example of usage of logger. This simply run and normally, or as it is here. Here org.apache.tools.ant.default logger, the logger used implicitly unless overridden with the dash logger command line switch. Here you can see and you can run ant normally, or like here. As example 2, we are considering getting Apache Ant, the short story. To get up and running with the binary distribution of Ant quickly, follow these steps. Step 1, make sure you have a Java environment installed. Step 2, download Ant. And step 3, uncompress the downloaded file into a directory. Step 4, set environmental variables, Java underscore home to your Java environment and home to your directory you uncompressed Ant to, and add $ open curly brace and home close curly brace / bin Unix, or in Unix, or percentage and home percentage / bin in Windows to your path. And step 5, optionally from the ant home directory you can optionally from the ant home directory run ant -f fetch.xml d dest equal system to get the library dependencies of most of the ant tasks that require them. If you don't do this, many of the dependent ant tasks will not be available. And step 6, optionally add any desired ant libs. Note that the links in the list above will give more details about each of the steps, should you need them, or you can just continue reading the rest of the more things in the documentation. The short story for working with Ant source code, not needed if you are working with the binary distribution, is 1. Get the source code. 2. Build Ant. Here you can see example build file in using Apache Ant. Notice that we are declaring properties outside any target. Since Ant 1.6, all tasks can be declared outside targets. Earlier version only allowed property, typedef and taskdef. When you do this, they are evaluated before any targets are executed. Some tasks will generate build failures if they are used outside of the targets, as they may cause infinite loops otherwise. And call, for example, we have given some targets descriptions. This causes dash project help invocation option to list them as public targets with the descriptions. The other target is internal and not listed. Finally, for this target to work, the source in src subdirectory should be stored in the directory tree which matches the package names. Check Java C task for more details here. Set global properties for this build. Create the timestamp. Create the build directory structure used by compile. Compile the Java code from $ open curly brace src close curly brace into $ open curly brace build close curly brace. Create the distribution directory. Put everything in $ open curly brace build close curly brace into my project dash $ open curly brace tstamp close curly brace .jar file. Delete $ open curly brace build close curly brace and $ open curly brace dist close curly brace directory trees. Now we are considering running Apache Ant. Runs Ant using the built XML file in the current directory, the default target. Here the class main command line entry point into Ant. This class is entered via the canonical public static void main entry point and reads the command line arguments. It then assembles and executes an Ant project. This in the package org.apache.tools.ant. Now we are considering running Ant via Java in running Apache Ant. If you have installed Ant in the do-it-yourself way, Ant can be started from one of the two entry points. The first method runs Ant's traditional entry point. The second method uses Ant launcher introduced in Ant 1.6. The former method does not support dash lib option, and all required classes are loaded from the class path, you must ensure that all required jars are available. At the minimum, the class path should include ant.jar and ant-launcher.jar, jars/classes for your XML parser. The JDKs required jar/zip files. The latter method supports dash lib, dash no user lib, dash no class path options, and will load jars from specified ant home. You should start the latter with the most minimal class path possible. Generally, just the ant-launcher.jar. Now we are considering targets in concepts. A target is a container of tasks and data types that cooperate to reach a desired state during the build process. With regarding API, we can consider class target, class to implement the target object with required parameters. This is in the package org.apache.tools.ant. Targets can depend on other targets, and Apache Ant ensures that these other targets have been executed before the current target. For example, you might have a target for compiling and a target for creating a distributable. You can only build the distributable when you have compiled first, so the distribute target depends on the compiled target. Any entries to execute the targets in the depends attribute in the order they appear from left to right. Keep in mind that it is possible that the target can get executed earlier when an earlier target depends on it. Suppose we want to execute target D from its depends attributes. You might think that the first target C, then B, and then A is executed. Wrong. It's wrong. C depends on B, and B depends on A. So first A is executed, then B, then C, then D. In a chain of dependencies stretching back from a given target such as D above, each target gets executed only once. Even when more than one target depends on it, thus executing D target will first result in C being called, which in turn will first called B, which in turn first call A. After A, then B, then C have executed. Execution returns the dependency list of D, which will not call B and A since they are already called in the process. In the process of dependency resolution for C and B respectively as dependencies of D, had no such dependencies been discovered in processing C and B and A, would have been executed after C is processing this dependency list. Now we are considering extension points. For example, your important build file may need to compile code. It might look like this. Extension points are similar to targets in that they have name and depends list and can be executed from the command line. Just like targets, they represent a state during the build process. With regarding API, we can consider class extension point. An extension point build files can provide as a place where other build files can add new dependencies. This is in the package org.apache.tools.ant. Unlike targets, they don't these extension points they don't need any task. Their main purpose is to collect targets that contribute to the desired state of their depend list. Targets can add themselves to an extension points extension points depend list via their extension of attributes. The targets that add themselves will be added after the targets of the explicit depends attribute of the extension point. If the multiple targets and themselves, their relative order is not defined. The main purpose of an extension point is to act as an extension point for build files designed to be imported. In the imported file, the extension point define a state that must be reached, and targets from other build file can join depends list. Of said extension point in order to contribute to that state. For example, your imported build file may need to compile code. It might look like here. Call graph, create directory layout here, and empty slot, then compile. Now we are for considering built-in properties in properties. Base dir, the absolute path of the project's base dir as set with the base dir attribute of project. With regarding API, we can consider class directory scanner, protected file base dir, the base directory to be scanned. This is in the package org.apache.tools.ant. Now we are considering property helpers. Here's the logic that replaces the $ open curly brace toString : sum dash id with the stringified representation uh, of the object with some ID inside the current build is contained in a property evaluator similar to the following code. The class property helper deals with properties, substitution, dynamic properties, etc. Um, uh, this is in the package org.apache.tools.ant. Now we are considering ant.build.clone VM. The value of the ant.build.clone VM system property controls how ant instruments forked JVMs. The Java and JUnit tasks support clone VM attributes to control JVMs on a task by task basis, while the system property applies to all forked JVMs. Now we are considering build.sys class path. The value of the build.sys class path property control how the system class path, that is class path in effect when Apache Ant is run, affect the behavior of class paths in Ant. The default behavior varies from task to task. Now we are considering Ant properties control in Javac. Ant.build.javac.source provides a default value for Javac's and Javadoc's source attributes. Common attributes of all tasks. All tasks share the following attributes: ID, unique identifier for this task instance, can be used to reference this task in steps in scripts. Task name, a different name for this task instance will show up in the logging output. Description, room for your comments. Now we are considering if and unless. Since Ant 1.9.1, it is possible to add if and unless attributes on all tasks that and nested elements using special namespaces. In order to use this feature, you need to add the following namespace declarations. And if and unless namespace support the following three conditions. True if the value of the attributes evaluates to true. Blank if the value of the attributes is null or empty. Set, true if the specified property is set. Now we are considering assigning namespaces in XML namespace support. Thus, instead of adding a prefix attribute, the typedef and task get the URI attributes which store the URI of the XML namespace with which the type should be associated. The class typedef adds a data type definition with regard to API. Adds a data type definition to the current project. Two attributes are needed: the name that identify this data type uniquely, and the full name of the class, including the packages that implements this type. This is in the package org.apache.tools.and.taskdefs. Adding a prefix attribute to typedef might have been enough, but XML already has a well-known method for namespacing. Thus, instead of adding prefix attribute, the typedef and taskdef task get a URI attribute which stores the URI of the XML namespace with which the type should be associated. Now we are focusing on antlib. A group of tasks and types may be defined together in an antlib file. For example, the file sample.xml contains the following here. Antlib. An antlib file is an XML file with the root element of antlib. Antlib's elements are Apache ant definition tasks like taskdef or any ant task that extends org.apache.tools.and.taskdef.antlib definition. The current set of declarations bundled with ant that do this are typedef, taskdef, macrodef, presetdef, scriptdef. A group of tasks and types may be defined together in antlib file. For example, sample.xml contains the following. It defines two types or tasks. If an script mapper, this antlib file may be used in a built script as follows here. The other attributes of typedef may be used as well. For example, assuming that sample.xml is in a jar file, sample.jar, also containing the classes, the following build fragment will define the if an script path mapper tasks / types and place them in the namespace URI samples : /acme.org. The definitions may then be used as follows. Now we are considering a type def in AntLib. The following fragment define a type called URL set. Type def adds a task or a data type definition to the current project such that this new type or task can be used in a current project. With regarding API, we can consider class AntLib. With regarding API, we can consider class typedef adds a data type definition to the current project. Two attributes are needed: the name that identify this data type uniquely and the full name of the class, including the packages that implement this type. This is in the package org.apache.tools.int.taskdefs. The following fragment define a type called URL set. The data type is now available to Ant. This class, the class com.mydomain.url set implements this type. Now we are considering macrodef. The following example defined a task called testing and runs it. Macrodef, this defines a new tasks using a sequential nested task as a template. Nested elements attribute and element are used to specify attributes and elements of the new tasks. This gets substituted into a sequential task when the new task is run. With regarding API, we can consider class macrodef. Describes class macrodef here. This is the package org.apache.tools.and.taskdefs. Now we are considering preset def. The following fragment defines Java-C task with the debug, deprecation, src directory, source directory, and destination dir attributes set. It also has src element to source files from the generated directory. Preset def, the preset definition generates a new definition based on a current definition with some attributes or elements preset. With regarding API, we can consider class preset def. The preset definition task generates a new definition based on the current definition with some attributes, so element preset. This is the package org.apache.tools.and.taskdefs. This can be used as a normal Java C task, for example, here. Now we are considering script def. When executed, the resulting task logs the value of attributes and the base dir of the first file set. Script def can be used to define an Apache Ant task using a scripting language. And scripting languages supported by Apache BSF and JSR 223 may be used to define the script. Script def provides a mechanism to encapsulate control logic from a built within an Ant task, minimizing the need for providing control style task in Ant itself. Complex logic can be made available while retaining the simple structure of an Ant build file. Script def is also useful for prototyping new custom tasks. Certainly, as the complexity of the script increases, it would be better to migrate the task definition into a Java-based custom task. With regarding API, we can consider script def. The class script def defines a task using a script. This is the package org.apache.tools.and.taskdef.optional.script. The following definition create a task which supports an attribute called ATTR1 and nested elements, one being file set and the other a path. When executed, resulting task logs the value of the attribute and the base dir of the first file set. Now we are considering custom components. For example, custom condition that returns true if a string is all upper case, could be written as follows. The interface for conditions to use inside condition tasks. This is in the package org.apache.tools.and.taskdefs. condition. Custom conditions are data types that implements org.apache.tools.and.taskdefs.condition.condition. For example, a custom condition that returns true if a string is all uppercase could be written as follows here, and adding this is the setter for the value attributes. This method evaluates the condition. Adding the condition to the system is achieved as follows. This condition can now be used wherever a co-and condition is used. Now we are considering log4j listener in listeners and loggers. Message events are logged according to their logging level, mapping directly to the corresponding log4j level. The class log4j listener is deprecated. Apache log4j is not developed anymore. Last release is 1.2.17 from 26 May to 2012 and contains vulnerability issues. Use the standard listener or your own custom listener instead. This listener which sends us events to log4j logging system. This is in the package org.apache.tools.and.listener. This passes the build event to log4j using full class names of the generator of each build events as a category. Build started, build finish, org.apache.tools.and.project, get started, target finished, org.apache.tools.and.target, task started, task finished, a fully qualified class name of a task. Here you can see build started and build finished, org.apache.tools.and.project, target started and target finished. In org.apache.tools.and.target, tasks, a fully qualified class name of a task, message log, a class name of one of the above, or so if a task logs a message, its class name is the category used, and so on. All start events are logged as info. Finish events are either logged as info or error depending on whether the build failed during that stage. Message events are logged according to their ant log level, mapping directly to a corresponding log4j level. To use log4j, you will need a log4j jar file and a log4j.properties configuration file. Both should be placed somewhere in your ant class path. If the log4j properties is in your project root folder, you can add this with the -lib option. If, for example, you want to capture the same information output to the console by default logger and send it to a file named build.log, you could see the following configuration here. Now we are considering default logger in loggers and listeners. Simply run ant normally. The class default logger writes built events to a print stream. Currently, it only writes which targets are being executed and any messages that get logged. This is in the package org.apache.tools.ant. Now we are considering installation instructions from the readme txt in Antwork plugin for Jext Java text editor in IDE integration. You have to enable Jext console to see the Apache Ant output, menu, edit options, then general panel, because Ant messages are directed to the Jext console. You can configure the Ant call in a Jext menu, edit options, then plugins options, then Antwork plugin panel. Here you can set Ant home directory and the path to your build file. You can start Antwork in the menu, plugins, then Ant, then work. Now in the appearing dialog box, you can enter the target which you want to compile. If a JavaC error occurs in the Ant run, an error list opens within Jext. With the double click on the error message, you jump to the error in the specified Java source file. Now we are considering Java Ant API. Here we can consider as an example package org.apache.tools.ant. Now this is the end of my presentation. Thank you very much for watching it.